Hi everyone. So in this video, we will be solving 21st March. Second question because most of the students did not solve this question today. Okay, because they did not pass the test cases in this question. It was the tough question you can say. Students find difficulties in solving this question, so I am solving this question. Okay. Also, I am solving this question with the guidance of the student who solved the 7 by 7 test cases in this question. Okay, so only one student I found who passed 7 by 7 test cases in this question. Okay, so what is the approach he told me? Based on his approach, I am solving this question. Okay, so why I am telling you guys this? Because see, I have not seen the question from my eyes. So I will ask the question. I will ask this to the student like how you have solved this, because today actually I asked to the many candidates like how you solved this question, but they actually did not pass the test cases. Only one student I got who passed all the test cases in this question. That's why I am using his approach to solving this question. Okay, so first of all, make sure to like this video, and second thing, before starting the question, today this kind of response I got from the students. Okay, so thank you so much, sir, all because of your course TCS NQT prep. Thank you so much for providing such content. The level of numeric question was same. Okay, again the next response. Yes sir, thanks for your help and structure guidelines throughout the preparation. Again, he did very great in the exam. Okay, and his approach only I will be using in this question. Again, uh, numeric I will get 12 plus, verbal 15 plus, reasoning 13 to 14, advanced coding one question class. Thanks for your effort, sir. Okay, everyone today appreciated me. I am in sky today because students are appreciating me a lot टुडे. सो थैंक यू सो मच. ओके, आप देख सकते हो कोडिंग बहुत ज्यादा आसान था. थैंक यू. रीजनिंग इंग्लिश सेम मॉक टेस्ट जैसा था. मतलब एवरी वन इज अप्रिशिएटिंग. थैंक यू सर, इट्स ऑल बिकॉज ऑफ योर कोर्स. ओके, सो टुडे एक्चुअली आई एम ग्लैड दैट स्टूडेंट्स आर appreciating so much our effort because on the result day only. ओके, मैं पहले से कितना भी बोलता रहा हूँ कि मेरा कोर्स बहुत अच्छा है, आप खरीद लो, आप निकाल पाओगे, टीसीएस क्रैक कर लोगे, बट जब बच्चे देके आते हैं एग्जाम तभी पता पड़ता है कि उसने कितना इम्पैक्ट छोड़ा. Right, and still if you have your TCS exam, if you, I know you have very less time to prepare, I would suggest to focus on these live tests. They are helping a lot of students. Okay, so you can just go in this section which is TCS NQT actual exam live test. Okay, in this, if you can see here, there are a lot of live tests provided, so you can use them for your practice, and definitely they will helping you out for clearing your foundation section. Okay, the link of the mock test series will be in the description. Let's start with this question. So the question says, okay, there will be total n number of soldier. We need to place the soldier. There are the values array given. There's a end number given. Each soldier number is chosen from the value array. No two adjacent soldier have the same number. The first soldier must be having the number 1. The last soldier must be having the number end. Find the total number of valid arrangements. Okay, so you will not understand the question like this. I will be explaining you. So basically they are saying there is a number given which is n equals to 4. Okay, n equals to 4. That means total 4 values will be given to you, like 1 2 3 4. Okay, so n is telling us the size of values array. Okay, now one n number will be given to us. Now they are saying the first soldier will be always 1. Okay, the last soldier will be the element which they have provided here in the end. So suppose 1 is here and 3 is here. Okay, because 3 will be the last soldier. Now we need to find all the valid arrangements, right? And the final output is 7. The condition is there can be no two soldiers who are adjacent and the number is same. For an example, 1 2 4 3, this arrangement is valid. But if I will say 1 1 4 3, then this arrangement is not valid because two soldiers are adjacent, right? That's why. So 7 valid arrangements will be, suppose 1 is here, 3 is here. Okay, so let's use 1. Can we use 1 here? No. So we can use another number. Can we use 1 here? Yes, we can use 1 here. Okay, in between we can use 2. In between we can use 4, right? So 1 4 1 3, these are the two valid arrangements. Now again, starting from 1 ending from last, these are the fixed two positions. Okay, now 2 I can choose here and I can choose here, right? So if I will choose here 2, I can choose 4 here. Then again, I can choose this arrangement. There will be 1, 4, 2, 3. These are the two arrangements. Okay, so these way we can find 7 arrangements like this: 1, 2, 1, 3, 1, 2, 4, 3, 1, 3, 1, 3, 1, 3, 2, 3, 1, 3, 4, 3, 1, 4, 1, 3, and 1, 4, 2, 3. Okay, these will be our 7 valid arrangements. Okay, in which no two soldiers are adjacent. Okay, and these are the valid arrangements, so output is 7. Okay, so this was the question. Okay, now most of the students today did not pass the test cases in this. Okay, I will be telling you the reason also. That student told me that why most of the students failed to pass the test cases. Okay, so see, let's start with the approach. How we will be solving this question? Approach is pretty easy. We will be directly using recursion. There is no need to use DP here because the recursion solution passed all the test cases. So we need to find the valid sequence, right? At the starting position, we will fix 1. At the ending position, we will be fixing 3. Okay. And now we will run our recursion solution. How we will run our recursion solution? We will be running a loop. We will be running a loop for all numbers, from the value as array. Okay. We will be fixing our index and we will be trying all the numbers there if the number can be fit there or not. For an example, we are running a loop on this array and suppose our index is this one. Okay, we will try with 1 here. So suppose 1 is here. Okay, so can we try 1 here? No, because the last number is same, right? So current index number should be not same as index minus 1, right? So 1 cannot be here. Okay, so we will not place 1 here. Then 2, can we place 2 here? Yes, so 2 we can place here, and then we will pass this arrangement, okay, to the next recursion, and we will do this index is fixed, right? So we will do index plus 1. So because for next index we need to find the another solution. Okay, now we will be having two choices. Either we can use this, okay, suppose at this index we are using 2. Okay, or we can use another number, suppose 3. We can use here 3 also. Okay, so that way our recursion will work. And how our recursion tree will look like, I will make a recursion tree so it will be easy to you to find out how our recursion is working. Okay, so this is our recursion tree. 1 is fixed. Okay, 1 is fixed, 3 is fixed. Okay, 1 is the starting number, 3 is the uh, uh, last number. So our recursion tree is working like this. So first, सबसे पहले for first index, okay, we will be using numbers from the values array 1, 2, 3, and 4. Okay, there we will be using all the values and we will be checking if we can proceed with it or not. So at the first index we will be trying 1. This is the first solution. We will be trying 2. This is the another solution. We will be trying 3. This will be the another solution, and we will be trying 4. So 1, 4, 3, and these are the blank spaces. Now these are the all possible 4 values which we can place, right? Then we will expand the tree. So if you will see here, the index is not matching. Like, if you can see here, the index is not matching. Index and index minus 1 is same, so this solution is not valid. We will drop it. Suppose this is a valid solution, then again we will expand the 4 solution here. Okay, for the next place, that means for index plus 1. So currently it was for first index, then it will be for second index. There will be 4 solution: 1, 2, 1, 3, 1, 2, 2, 3, 1, 2, 3, 3, 1, 2, 4, 3. These will be the 4 possible solution. This can be a valid arrangement. Okay, this is fine. And now we don't have any index, so count plus plus. Okay, then like this is the one valid arrangement. Then 1, 2, 2, 3. Again, both index are same. Drop this solution. 3 3 both are same, again drop this solution. 1 2 4 3, this is the valid arrangement, so count plus plus, again this is the valid arrangement. So this kind of recursion tree we will be using for each and every number. We will be expanding our tree and we will be counting the arrangements. This will be our solution approach. I hope you guys got it. Okay, so for that, okay, how we are writing the code? See, first we are taking the input of n. You can use c in n, and then you can run a for loop and you can take the values array in the input. Then at the end you can use c in end, right? These are the three values which we need to take as input. Then we will be passing that in our count arrangements function, n values and end. Okay, so all these three values we are passing here. Okay, now this is the basic thing which I wanted to discuss. Okay, so now at the first index we are assigning 1. At the last index, we are assigning our ending number, which is 3, as given in the input. Our starting count is 0, number of possible arrangements. Then in the solve function, we are passing 1, because from one index, we need to start the filling of the arrangements. We are passing our array, we are passing values, count, and n. Okay, everything we are passing. This is our arrangement array. Okay, this is our arrangement array. This is our values array. This is our count of the total number of arrangements, and this is the size. Okay, then this is the function, right? So first we are checking our test cases. Okay, the first base case, the base case is, okay, if the index is equals to n minus 1, that means we reached to the n minus 1 position. Okay, if we reach to the n minus 1 position, what we will be checking? If index is not equals to index minus 1. Okay, if the index is not equals to n index minus 1, that means both numbers are not same, then we will be doing count plus plus, right? This is the thing which we need to do, because the no adjacency, two numbers can be same, so we will be doing count plus plus. This is our base case, right? And we will be returning. Okay, next we will try all our values for filling the arrangement which we discussed in the approach. So we will be starting our loop from 0 to the values dot size, right? So this loop we will be continuing. We will be assigning the one by one all the values in the val variable. Then we will be checking if val is not equals to ARR, arrangement of index minus 1. Okay, so if both are same or not, if both are same, then we will be dropping. So then we will be not using the recursion logic and we will be dropping that value, right? Both should be not same, the current value and the index minus 1, right? So we are checking this condition. Then at the current index we will be assigning that value which we have discussed. So suppose this is our arrangement 1 and 3. Okay, so in the loop, suppose first we have 1. So now these are our value, right? 1 2 3 4. So for this place 1 came, so this condition will fail, because 1 and 1, these both are same, index minus 1, right? So this will drop. Now there is 2, right? So we will place 2 here. So ARR of index will become 2. So this will become 2, and then we will pass this arrangement for the next index. So this index we will be filling, right? So we will be passing index plus 1, ARR, values, count, and n. So this way we will be getting all our solution through recursion. The main thing why the test cases were failing, the student told me everywhere we need to use the pass by reference. Okay, pass by reference we need to use everywhere. If we are not using the pass by reference everywhere, then the test cases were failing in the actual exam, and this was the actual solution which the student did, and he passed all the test cases. Okay, I hope the solution is clear. I hope the question is clear. Thank you so much for watching this video. If you want to prepare, you can purchase the TCS NQT mock test series. The link will be in the description.